Hey guys, let's solve the problem 260, single number 3. Okay, so let me just tell you what this question is saying. Suppose I have an array 5, 1, 2, 2, 4. Let's take this. So I have this array, and in this, what it's saying is every value is in pair. Okay, except two values. These are not in pairs, else everyone has the pair. So we have to return the number which are in not in pairs. Okay, so what can I think of? Is a simple approach would be uh, let me just clean this up. First approach that I can think of is suppose I'm standing at 1, then I will take a pointer and keep on going like this, and if I found a 1, then I just simply move to the third value, second value, else I'm going to put a resultant and add 1. Okay, now suppose I'm going like this and I got a 1 here. So I'll just simply move in this way. I'm at 3. So I'm searching for 3 whole. 3 is not there. So what I'll do is add a 3 in my result. Now again I'll put to the 5. 5 is not there. I'm going to put this 5. And the moment I got, I'm just going to return this. Okay, this is my first approach, in which I'm going to iterate the array 2 times, so it would be n square. Okay, in this approach, my time complexity was n square and space complexity is 1. Okay, now how can I optimize this? What can I think of is, suppose if I take a hash map. Okay, and if the value is not there, I put the value and mark the count. Suppose 1 appears 1 time, 3 appears 1 time, 5 appears 1 time, again 1 appears. So I'm going to put this 2. 2 appears 1 time, 2 again appears, so it will be 2. So then I will iterate over and see which are the values that have 1 count. So I'm going to simply return this array. So in this, the time complexity is n square and space complexity is n. Okay, n square plus a small amount of complexity could be n by 2 to iterate over this, but it would be remain n square. Okay, it will still be n square. The time complexity is n and space complexity is also n. Okay, my bad. So again, a second approach was n and time complexity n, space complexity n. Okay, now how can I optimize further? Okay, this is my first approach, this is my second approach, and now the third. Third approach is quite bit tricky. Okay, as it needs bit manipulation. Okay, now I'm giving you a term called XOR, in which if I have similar value, it will give me 0, and if I have a dissimilar value, it will give 1. Okay, with this approach, what I'm doing is, suppose I'm going to XOR between each and every value. Okay, this will give me what this will give me, an XOR of whole array. Now I'm giving you a property. Okay, suppose if I have 1, 3, 1. Okay, and suppose if there is only one element that is occurring one time. In this, what I will do is I'm going to XOR each and every element, and since 2 XOR 2 would be 0, means X XOR X always give me 0. So this will give me 0, this will give me 0, and only 3 will left. So I can simply return 3, means XORing the whole array, and whatever the value will be, I'm going to return that. Okay, this is if you go to single number 1, this is the approach you can follow. But I have 2 elements here. So what can I do is I'm going to XOR whole array. But in the end, there will be value of P XOR Q. It will give me some value. Okay, means P will be 3, suppose, and Q will be 5, so it will give me some value. Okay, but this value is not of my use. Okay, what can I think of is, suppose I convert this 3 into a bit, it would be give me like this, and if I convert 5, it would give me this. Now, all this array will give me a x value like this. This would be the value that I will get after XORing a whole array. Now you will say, what is the use? Suppose if I see if there is 0, means both value are same. Both of these value are same. But the moment I go to this value, I'll see this. There is a 1, there is a 0, and there is a 1. So what I will do is I group all the elements according to 0 and 1. According to this set of value, this bit, I'm going to divide whole array. Okay. Now I will see 1. Do 1 belongs to this position? Okay, now let me just clean this up and just give you a 1, 3, 5, 1, 2, 2. Now my answer was coming is 1, 0, 1. So I'm going to check the second value of each number. If I'm going to check the second bit of each value and group them accordingly. Okay, now group 0 and group 1. Now 1. Where 1 belongs to? The bit value is 1. I'm going to see the second value. So I'm going to put 1 here. Okay. Now 3. 3 is 1, 0, 0. Again, this is, so I'm going to put 3 here. Okay. Now 5. 5 I'm going to put here. 1, 2, and 2. So I have grouped them according to their bit value. And let me just write for you what is the bit value. 0, 0, 1. 1, 0, 0, 0, 0, 1. And with this 1, 1, 0, 0, 1, 0, 0, 1, 0. So I have grouped them according to this value, the second bit. Understood? Now, if I XOR all this group wise, this will cut, this will cut, this will cut, this will cut. In the end, I will get 3 and 5. And this, I have to return this. Understood the concept? This is a bit manipulation, a little tricky to understand if you don't know the bit manipulation. But yeah, it is a really good question. Okay, so let's go to this third approach. Okay, now, first, what I need is to find the XOR of whole array. So what would be? Okay, now I have to check which is the lowest. I have to check which bit is set from the lowest. Okay, so what I will do is set bit index 0 for I in range 0 to 32. So from 0th bit to the last bit, it would go like this. Suppose my bit is 1, 1, 1, 1, 1, 1, 1. In integer, there is 32 bits. So I'm going to check from this, then this, then this. So 0, 1, 2, 3, 32, 31. Okay. Now, what is the value? Temp equals to XOR left shift I and 1. If temp set with index equals to I and break. With this, I got my lowest set bit. Okay. Left shifting, right shifting each and every time and getting with the end means if my value is this and I have to find the first value, so I'm going to left shift right shift one time, so this will become like this, and I'm going to XOR with 1 or end with 1, so this will give me 0 and this will cut. This will all cut. I will just hit this one. Okay. Now group them according to the set bit value index value. Okay. Now I'm going to put like this for I in nums. Now value of index would be I XOR set bit index and y. Okay, now if val equals to 1, then rest dot dot XOR equals to I as rest. Instead of storing them and grouping them, I'm just XORing the value of the whole group. Okay, now let's run this. Has been accepted. Let's try to submit this. Yeah, hope you understand the concept of this. Quite efficient. Hope you understand the concept of this XOR value, and if you do, just give it a like and subscribe. See ya.